Alrighty, so in this video, we're going to continue our discussion on CT scans, or CAT scans. Where we left off last time was we had our prototype scanner, which was able to show that this is a feasible process, that you can have an X-ray source shooting X-rays, a beam of X-rays, let's say, and you'll have your object, whatever it is, and back here you'll have a detector. And what would happen is you would have your object slide or translate across, let's say on a table, so that this beam goes through the full width of the object, and the detector behind it is going to detect whether X-rays hit or don't hit. Basically, are they absorbed or are they able to pass through? And once you go through one full pass, then this object is rotated around by 1 degree or 2 degrees or however, and then the object slides back the other way. So now the beam goes through again, coming back the other way. And this process continues until such time as the object has been rotated a full 180 degrees, and this beam can sweep through the full object all the way around. So that was the prototype, and it worked. But it was, of course, inefficient, took a long time for images to be produced, and, of course, for the computers to do their work. Now, they were able to increase the efficiency with the filtered back projection and things like this. And they finally had their first generation actual machines. So for the first generation, what you would have is a machine basically that could image the brain. That's pretty much what it was good for. Again, these were time-consuming enough such that you could not image clearly a part of the body that had a lot of motion to it. So the heart beating or the lungs as you breathe or things like this, that motion will blurry the image because it's taking so long to produce the image. So the first generation was pretty much for the head region. And what would happen is you would have, let's say, a patient lying on a bed, and they would have their head inside of this machine. Okay. So there's a hole in this machine right here where the head would go. It would be able to be put in. And you'd have, up here, the X-ray source sending a beam of X-rays straight down through. And down here you'd have a little detector detecting those X-rays. And so the way this machine would work is the X-ray generator and detector are on this track. Okay. And so they can translate, they could slide over to the left. And in doing so, it'll sweep through the slice in the person's head, let's say. X-rays going through, goes all the way around. Then this whole machine would rotate, the X-ray part of it, or the CT scan part of it, not the bed, would rotate by 1 degree. So now the detector's over here, sending X-rays this way, or the generator's over there, sending X-rays that way, and now it'll slide back and forth this way. And then it would rotate again, and so on, until, as before, you go a full 180 degrees. And so if you had kind of a front-facing view, it looks like this. Here's the machine. Here's the track, the little X-ray source and the detector. And here's the hole where the head would be placed in. And so, as I said, this generator and detector attached as one would slide to the left, sending the beam straight through until the detector and the generator are over here. Then this part, the circular part, would rotate a little bit and then slide back that way, and so on down the line. Back and forth, rotating around a full 180 degrees. Now, this was good. It was still a little slow. It still took sufficient amount of time where things like chest imaging and things like that were not feasible. Basically, this would take on the order of about 20 minutes per slice. And when I say slice, the reason I say slice is because if you think about what's happening here, if you have, let's say, a sphere, so a solid ball, and you have your X-ray generator sending a beam through, and the detector down here. Well, as this source slides left and right, you're basically allowing the X-rays to be absorbed by this kind of slice in the ball. And so you're going to create an image of a single thin slice of the brain or of the ball or whatever object it is you're imaging. And so then you'd have to slide the object in just a little bit further into the machine, and it'll take the next slice. Goes all the way around the body, 180 degrees, creates an image of the next slice. Then you slide the body into the machine a little bit more, and you go the full 180 degrees all over again. Until you've gone from the tip top all the way to the bottom of this object, creating slice after slice after slice, and then you put all the slices together to recreate the three-dimensional object you started with. Well, if each slice takes 20 minutes, this is a very long process. So they had to come up with a way of upgrading the machine to make this faster. And so in the second generation, they decided, well, look, why don't we, if we want to create images quicker, then we need more X-rays going through and being detected on the other side per second. The more X-rays that go through, the faster the images can be taken. So for the second generation, you again had pretty much the same working kind of a machine. Only this time, the X-ray generator, instead of creating a pencil beam, a thin beam like a laser of X-rays, this time it creates kind of a fan beam type of thing. And you have some set of detectors. Instead of just one single detector, you may have 4 or 5 detectors around here. And so at this, and of course the same thing happens, right? You rotate around and translate, slide back and forth just like before. But now, since you have this fan beam configuration of X-rays, you get a bigger piece of the slice with each path. Instead of having a single little line that cuts through the object. So obviously, if you go across, you're only getting this line of stuff. With a fan beam like this, when you go across the object, you're getting all of this piece in each snapshot. So you get a lot more of the image per pass, and so you don't have to go through and take as long to create the same images as before. So this was a big, noticeable improvement. In fact, this made the scan time per slice of about 20 seconds up to about 3 minutes. So from 20 minutes down to about a minute or two per slice is a huge improvement. Also, with increases to computer science at the time, computer languages, they were using Fortran, and then they started using machine language and other things. The ability for the computer to do the calculations increased exponentially. Computers weren't as expensive. You didn't have to have a big old huge private room that sat one single computer that had to be cooled. You didn't have to have such a big supercomputer. Now you can have a computer in the hospital room itself. It didn't have to be sent off to wherever the fancy computer was. And so now all of a sudden you had the ability, being that each slice only took about a minute, people can feasibly hold their breath that long. So now you were able to scan the full body instead of just the head. So that's a huge improvement. Then they had a third generation, which is very similar to the second generation, except now instead of the rotate and translate version, all you had was, you still had the generator that made a fan beam. Now you had a whole arc of detectors, so way more detectors than before. And now this thing just rotated a full 180 degrees all the way around to take one slice. Then the person would be moved in a little bit, and it would rotate back the other way 180 degrees. And then you'd move in, and another 180 degrees back, and so forth. So now you didn't have to slide the beam across and then rotate a little bit and then slide it across again. Now it's purely rotational. You're just rotating the beam around. You have this whole series of detectors. Now you're down to basically doing each slice in about half a second. Now we're really getting quick. And computers were working very fast at the time. And so, like I said, you'd get about 2 pictures per second in this type of thing. And then finally, the most modern now makes use of what's called slip ring technology and solves one of the big problems of the third generation, which was, notice when this thing rotates 180 degrees, let's say counterclockwise, it stops, and then the person goes through, and then it's going to rotate again 180 degrees to get the next slice. But notice, when it does so, it rotates back the other way. Okay, so it doesn't just keep going around the way it was. It has to stop and go back the other way. The reason is because, obviously, this machine is wired. You have power cables going through it. You've got the data cables coming out of the detectors and so forth. So if all of this is wired, if you try to rotate all the way around and keep rotating in the same direction over and over and over again, those wires will get all tangled up. So instead, it would rotate 180 degrees and then stop. And then to get the next picture, it'd rotate 180 degrees back the other way, untangling the wires. So you never went around a full way, you never tangled the wires. But that made for a slower process. You had to rotate around, then it would stop, then it would rotate back. Well, with slip ring technology, that allows you to connect power and wires and things without it being a solid connection. So instead of plugging the wire in, let's say, instead what you would have, if this is the rotational part, and on it is the little X-ray generator and the detectors and stuff. Well, just outside of that, which is rotating, is basically like a brush of wires, very thin cables, wires. It looks like a brush, filaments. Since they're made of copper, since they're made of metal, they could send power through. The current can run through this brush, these filaments. But these filaments, even though they're touching the machine part of it, so it's supplying power, if it's touching, the circuit's complete, they're not connected to where they're locked into place. So you're basically just touching these wires without the wires being connected in. With that, you're able to have rotation without, the wires getting all tangled up. So if you think of, like, let's say a drill, electric drill or something like that, how do you have power to the part which causes rotation without having the wires that give that power tangle up? Well, things like this, slip ring technology and stuff, allows it to happen. Well, with that, what now happens is, here's kind of a side view. Here's the machine. Here's the little bed the person's on. Well, now this rotates, and it just keeps rotating continuously as the person is sent into the machine. There's no stopping and starting. It's not, it rotates around 180 degrees, then you go in an inch, and then it rotates another 180 degrees, then you go in another inch. Now it's kind of like a spiral sliced ham, where it basically makes this spiral shaped set of images. So as the person's sliding in, this is rotating around them at the same time, continuously. And so instead of a bunch of slices like this, you get this spiral shape instead. But it's all the same data. And so now they take this data with their computers and are able to, again, get the same type of image. You get the full body depiction, three-dimensional. But now the process is very quick. You can do a full body scan in about 30 seconds. From head to toe, and get a complete 100% representation, three-dimensionally, of the inside of the body. And so that's how these CAT scan machines have evolved over time. As technology increased, as they came up with more and more efficient ways, not only of doing the mathematics behind the scenes, but also in terms of how to increase the efficiency of the X-ray generation and the detection and things like that, they're able to take a process that started in the prototype at 9 days and eventually got it down to 20 minutes and then 2 minutes and then half a second, and now we're down to literally a full body scan is on the order of about 30 seconds. Very powerful. And now we have a means of imaging the body inside and out in 3 dimensions, create a model on the computer that you can rotate around, zoom in, look at different parts of the body, what's behind this organ, what's in front of that organ, all that stuff, purely from the power of, number 1, X-rays, but number 2, mathematics and computational power. That's what computerized axial tomography, CAT scans, are all about. So this was clear. I hope you learned a little bit and got kind of a feel for how the technology has improved. And of course, like I said, this is basically the standard of what we have. You go to the hospital, you need to get a CAT scan. That's the kind of machine it's going to be. It's going to be a continuous. You're laying on the bed. The machine turns on, it spins around. This X-ray generator is sending out a fan beam of X-rays on the other side. A bunch of detectors are sitting there just detecting how many X-rays are coming in. And as it's rotating around you, you're sent through the hole in the middle of the machine, and it creates all these slices of imaging, one continuous spiral slice, in fact. That data is sent to the computer, it's processed, and spits out the 3-dimensional images. Anyway, that's all I have for this particular topic. Until next time.